All right, today's lesson, 4.8 part 2 on complex numbers. We are going to work on adding, subtracting, multiplying, and dividing complex numbers. Now I'm going to go through these examples pretty quick, and not all examples, so make sure you enable the pause button if needed, and then also you can go look on the website to see the remaining examples that we don't go over. Okay, so first off, if you have a number 5 plus 2i, 5 is the real number part and 2i is the pure imaginary number. So together they make a complex number. They cannot be added because they are not like terms. So the standard form of a complex number is a plus bi. So the first thing we're going to do is work on adding and subtracting complex numbers. So you do this just as if you were combining constants with maybe like 2x and 2x squared, things like that. Just add the like terms. So for number 1, if it helps you out, you can reorder it. So put the numbers together first, negative 11 and 9, and then put the i's together. So negative 11 plus 9, negative 2, plus 5i. Okay, let's jump down to number 4. If there's a subtraction sign, a minus sign, you need to treat that like a negative 1 in front of the parentheses and distribute that negative 1 to both items. So we have a 6i, and then that next part, if you distribute that negative 1 through, it's going to be negative 14 plus I. Negative 1 times I would end up being plus I. And then finally that last part is still going to stay the same, plus 5 minus 3i. So then add like terms. So you have a 6i, an I, and a minus 3i. So 6i plus another I, 7i, minus 3i, 4i, negative 14 and 5 minus 9. Just flip it around so that the number part comes first, the real number part. Negative 9 plus 4i. All right, let's jump down to the next set. Number 5. So this time we are multiplying these complex numbers. So first of all, we have the pure imaginary number 2i. We're going to distribute that to both parts here. So 2i times 8 would end up being 16i. 2i times negative 3i. So 2 times negative 3 would be a minus 6. I times I squared. So remember that I squared is just negative 1. So we go 16i minus 6 times negative 1. So negative 6 times negative 1 would just be 6. 16i plus 6, just flip it around, 6 plus 16i. All right, let's jump down and do number 8. This time, we're not just going to distribute, we're going to FOIL. First, outside, inside, last. So we're going to take 2 times negative 5 to get negative 10. 2 times negative 3i to get minus 6i. Continue on with that one. So we got inside negative 4i times negative 5 would end up being plus 20i. And then last, negative 4 times negative 3, positive 12. I times I squared. All right, so we have negative 10. So we can go negative 6i plus 20i would be positive 14i. And then at the end we had plus 12 times, remember I squared is just negative 1. All right, so now we can make negative 10 minus 12 would be negative 22 plus 14i. All right, number 9, if it's all squared like this, don't forget that you have the capability to break it apart. So something squared is just the same thing times itself. So now we can do first, outside, inside, last. So FOIL first would be 36. outside would be minus 12i, inside minus 12i, and finally last, negative 2 times negative 2 is positive 4, I times I squared. Remember that I squared is negative 1, so that whole term will just end up being negative 4. So you go 36 minus 12i minus another 12i minus 24i. Remember that whole part's just going to be minus 4. So 32 minus 24i. Number 10, you first got to FOIL and then combine it with that minus the other complex number. So FOIL, first 9, outside 3i, inside 63i, and last 21i squared. And then we have a negative 1 being distributed. So if you would distribute negative 1 to all that, it'd be minus 4 minus 2i. And then you can add like terms. So let's simplify. I'm going to simplify here first. 9 plus 66i, 21 times negative 1 minus 21. I squared is just negative 1, remember? Minus 4 minus 2i. Combine like terms. So we have a 9, a minus 21, and a minus 4. So that'd be negative 25. 9 minus 25, negative 16. And then we've got 66i minus 2i plus 64i. All right, let's move on to the next page. So if you have two numbers, two complex numbers that are the same thing except for the symbol in between them, one's a plus and one's a minus, those are called complex conjugates. So when you multiply two conjugates together, you're always going to get a real number. This is going to come in handy in a little bit on our problems. So if we take 8 times 8, we get 64. And then you do outside minus 8i. And then inside plus 8i. And finally last minus I squared. Notice that those 8i's end up canceling out. It's kind of like the difference of squares, how that O and I term end up just canceling. So you end up getting 64 minus, remember I squared is negative 1. So it's going to be 64 plus 1. Oops. 64 plus 1, or just 65. So let's look at 12 real quick. So you do first, outside and inside are going to cancel. If you want to write them down, you can. You don't have to once you get the hang of this. 20i minus 20i, and then finally last, minus 16. I squared is going to be a negative 1. So we go 25 plus 16. Because these end up canceling. And then negative 16 times negative 1 will end up giving you positive 16. All right, so on to dividing. So remember that I is the square root of negative 1. So this would be like 10 over 2 squared and negative 1. So remember that we cannot have square roots on the denominator. To get rid of it, we need to rationalize the denominator. Well, we can do that same thing, but with our I term. So what's going to be helpful is to simplify first. So if we would simplify this one first. All right, so what we're going to do is simplify first. So we can get rid of, we can take a 2 out of the numerator and the denominator to make it 5 over I. This is going to be helpful because then we won't have to simplify later. Well, we might still, but it'll be easier numbers. All right, so we got 5i, and then I times I is negative 1. Can just be written negative 5i. Okay, let's do one of these here, number 15. So we can just take this again, times I over I. That will satisfy the denominator to make it be a whole number. Don't forget that the numerator, that's like in parentheses, so you need to distribute the I to both of them. So on the top, you're going to get 28I minus 8I squared all over 4I squared. So we're going to get 28 minus 8 times -1 over 4 times -1. 28 plus 8 all over 4, -4. So let's see if we can simplify that. 28 plus 8 would be 36 over -4, -9. All right, let's go down to 17. So if it's not just an I in the denominator, if it's not a pure imaginary number, if it's a complex number, 5 minus I, you need to multiply that by the conjugate, 5 plus I. So we're going to go times 5 plus I. So the top, you can just distribute the -2. But for the bottom, you've got to FOIL that out. So if you remember, when you multiply complex conjugates, it's just going to be the first and then the last, because the inside and outside are going to cancel. I'm going to go ahead and write it all just so you can see that. Plus 5I minus 5I minus I squared. So remember that plus 5I and minus 5I just cancel in the middle there. And then just rewrite what you've got here. So we've got -10 minus 2I all over 25 plus -1. So 25 plus 1. So -10 minus 2I all over 26. And then notice all three numbers have a 2 in it that can be taken out. So we're going to take out a 2 out front. So what you're actually doing is factoring a 2 out on the top, which would be -5 minus I, and you're factoring a 2 out of the bottom, which you're left with 13. So what happens with those 2's is they end up canceling. So then your final answer would be -5 minus I all over 13. All right, let's do one more of those. Let's do number 20. So we're going to multiply by the conjugate of the denominator. 2 plus 4I. 2 plus 4I. So this time, not only do we just need to FOIL the denominator, you also have to do it to the numerator. All right, so remember that it's like having a parentheses there. So you're going to FOIL it. So we go first, I'm just going to jump down to this next line here. First, outside, inside, last. So first 2, outside 4I, inside 16I, and finally last 32I squared. All over. If you're getting the hang of this, it's just the first one and then the last one, because the inside and outside end up canceling. So now simplify. So 2 plus 20I minus 32, because remember I squared is -1. 4 plus 16. So we get on the top -30 plus 20I. And then on the bottom we're getting over 20. Oops. So then you can take a 20 out at or let's not take a 20 out, let's just take a 10 out. So if we take a 10 out of the top, you're left with -3 plus 2I. Take a 10 out of the bottom. You're left with a 2. Remember, those 10s will cancel, so you don't need to keep those 10s in your final answer. And this would be the simplified answer. So -3 plus 2I all over 2. All right, so your assignment's at the bottom of the page there. If you want to find